Alright, imagine this. You're cruising at 50,000 feet over the Atlantic, sunlight blazing through the cockpit windows. Suddenly, out of nowhere, a shadow slams into you at 2,000 miles per hour, like a cosmic switch flipping. Darkness swallows the sky. The temperature plummets. And you're not crashing, you're flying straight into the heart of a total solar eclipse. This isn't sci-fi, it's NASA's wild plan to chase the moon's shadow off Iceland's coast. But why go to such extremes? Let me break it down. First off, NASA isn't just doing this for the thrill, though honestly, that moment Clem described sounds like something out of a space thriller. The real goal? Capturing data we can only get during an eclipse. Those cameras in the WB-57's nose cone, they're hunting for solar prominences, those fiery plasma loops on the sun's surface, and nanoflares, which, despite the name, are explosive enough to rival thousands of atomic bombs. But here's the kicker. Nanoflares might explain why the sun's corona is 1,000,000 degrees hotter than its surface. That's like a campfire heating the air around it more than the logs burning. It defies logic. Personally, I think this is where science starts sounding like magic. How do these tiny explosions shape something so vast? And what else are we missing? Now, let's talk about the plane itself. The WB-57 is a relic of Cold War tech, a bomber turned eclipse chaser. There's something poetic about repurposing a weapon of destruction into a tool for discovery. But NASA's not the first to get creative with eclipse missions. In 1923, the U.S. Navy sent biplanes up with zero success. Then in the 70s, Concorde tore holes in its roof to outrun the shadow at Mach 2. What's fascinating is how each era's tech shapes what we can learn. Today's stratospheric flights are leaps ahead, but I can't help wondering, what will future missions look like? Will we send drones? Hypersonic jets? Or maybe a satellite that can park itself in the shadow indefinitely? But let's zoom out. Why does any of this matter? Caspi's right. Space weather isn't just a space problem. It's an Earth problem. Solar storms can fry satellites, knock out power grids, and endanger astronauts. Understanding nanoflares could be the key to predicting these events. Think about it. If we can't forecast a solar storm, how do we ever expect to colonize Mars or protect our tech-dependent civilization? This mission isn't about cool photos, it's about survival. And yet, there's still that human element. Caspi mentions how few people ever witness totality. Standing in the moon's shadow isn't just a scientific experience, it's existential. You're forced to confront how small you are in the cosmic dance of celestial bodies. It's humbling, but also empowering. Like, yeah, we're just specks, but we're curious specks. We're the species that builds planes to chase shadows and asks, what's next? So here's my takeaway. This mission is a metaphor for humanity's relationship with the universe. We're always racing toward the next mystery, using every tool we've got. Sometimes we fail. We've come a long way since those 1923 biplanes, but every flight, every data point, adds to the story. And honestly, the fact that we're still asking these questions might be the most remarkable eclipse phenomenon of all. What do you think? Should NASA's next step be? Let me know in the comments.